Okay, here's an example of how to use I.C.E and K.C. to find concentrations at equilibrium. So let's take a look at our question. So we have hydrogen bromide decomposing, and we have the K.C. value. And then it tells us our initial concentrations of HBr, and then we're asked the equilibrium concentrations. So we're going to set up our I.C.E chart, and then this question's not that bad, but the math involved gets tricky. So you set up your I.C.E chart. If you have 0.09 in 2 liters, we're just going to divide it to get that concentration, and that would give us 0.045 moles per liter. And then initially we don't have any of the gas of hydrogen or bromide, so we can assume those are 0. Your change based on that ratio, we're using up our reactants, so minus 2x, and then your products are being formed, so plus x, because there's just a 1 in front of those 2 compounds. Then at equilibrium, we can add our columns, 0.045 minus 2x, and then x and x. So what we're trying to find is the concentrations of each of the gases at equilibrium. So we can use the K.C. expression to help us with that. So our K.C. expression is the concentration of H2 times the concentration of Br2 divided by the concentration of HBr, but we have to make sure to raise it to the power of 2 because of that coefficient in front. So now we can use these values at equilibrium to plug in, and you know the K.C. value, so we can also replace K.C. So we have 4.2 times 10 to the negative 9 equals, this would be x and this would be x, so I'm just going to write on the top here x squared over the concentration 0.045 minus 2x, and this was also squared. So now our goal is to find x. Once we have x, we can plug it in to all of our things at E to find our concentrations. So to find x, we want to square root both sides to get rid of those squared symbols. So we'll have the root of 4.2 times 10 to the negative 9 equals x over 0.045 minus 2x. We'll get this out of the denominator by multiplying it to the other side and then distributing this radical through the brackets to each term. So we'll have the root of 4.2 times 10 to the power of negative 9 times 0.045 minus 2x equals x. So as mentioned, distribute that through. Then we want to collect x to one side and our number to the other. So what we'll see here, once we distribute, we get 2.916. Keep this value in your calculator. Minus 1.296 times 10 to the power of negative 4. Again, keep this in your calculator. And then this has an x with it because of the 2x. And then that will equal x. Collect x to one side, so we'll add. And add that on over, but we do know there's a 1 here, so we'll have 1.29 times 10 to the negative 4. So it's a really small number, but that's okay. And then you would divide both sides to get x alone. So when we do that, you'll find that x will equal 2.9 times 10 to the negative 6. Once you solve for x, we can go ahead and plug it in here, here, and here. So you'll find out the concentration of hydrogen gas will equal the concentration of bromine gas, which is 2.9 times 10 to the negative 6 moles per liter. And then the concentration of HBr will equal the 0.045 minus 2 times 2.9 times 10 to the negative 6. And that will give you 0.045 moles per liter. And that is about it for this. If you found this video helpful, please like and subscribe. If you have any other examples you would like me to do, you can leave me a comment in the, you can let me know in the comment section. Thanks for watching.